Okay, so this is where we left off. We're in 3.5 now. Just powering through these notes. 3.5. There we go. So now what we'll be doing is we're looking at this table, and we need to identify where the horizontal asymptote is, just based off of looking at the table. Now remember, the horizontal asymptote is the infinitely to the left. So I know negative 500 is not infinity, but it's a very, very, very large negative number versus this. And as I mentioned before, those end behaviors are going to be about the same value. So that your answer for the horizontal asymptote is going to be, I like fractions. You can leave it as 1.5 though, but it is 3 halves. I'll go ahead and write or 1.5. And the reason I'm looking for is as x goes to infinity to the right, that function is getting closer and closer to 3 halves or 1.5. And same thing as, should have wrote smaller, as x goes to negative infinity, that function is getting closer and closer. It's not exactly, but it's closer and closer to 3 halves. So now let's look at the vertical asymptote. Now as far as the vertical asymptote is we want to see where we have an undefined x value. So let me change color. We have 2 undefined x values. This one and this one. Now which one do we actually care about? Is we care about the one whose, how do I want to phrase it? If you look at the y values on either side, that one is infinitely large, like this is, I know 251 is not infinity, but it's very, very, like it's getting larger and larger. And this side is negative. Whereas if you look at these two values are really, really close to being the same thing. And I'll get to that one in the next one for a reason. So we're looking at a vertical asymptote at x equals negative 1/2. Again, I like fractions, but if you write out negative 0.5, you'll get full points. So what's your reasoning? I'm still looking for that behavior as x approaches negative 1/2 from the left, the graph of f. Because on the left side of negative 1/2 it's negative, we're going to negative infinity. Whereas as x approaches negative 1/2, on the right side, f is going to positive infinity. It's going up, positive values. Kind of wish I color-coded this one. As I mentioned, this one is going to be your whole because we have the same value on either side. So how do I want to phrase this? I don't want to write f of 2 equals 1.6, but I hope you agree that 1.6 is the value that they're getting closer and closer to on either side. But as a fraction, that's 1 3/5, so I'm going to write it as 8/5. So it's a whole at that ordered pair of 2, 8/5. Now again, you don't want to write f of 2 equals 8/5 because that's technically wrong. F of 2 is undefined. That's what's stated right here. But your reasoning is as x approaches 2 on the left side, that function is getting closer to 8/5. And again, I will accept it as if you write or 1.6. I just like fractions. And as x approaches 2 on the right side, it's getting closer to that same value of 8/5. So now we have enough to state the domain and range. The domain should be pretty clear to you because they tell you the undefined values. So the domain, let's do this. I thought I changed colors, but that's okay, I'll stick with this. Negative infinity until negative 1/2, union negative 1/2, until the other x coordinate that's undefined, which is 2, and then from 2 to infinity. Whereas the range, you have to pay attention. Which occurs first? The 3 halves, the 1.5, or the 1.6 that you cannot actually see? Well, if you think about it, 1.6 is definitely bigger than 1.5, so 3 halves happens first. So negative infinity to 3/2. And if you change any of these to decimals, you'll be fine. You'll get full credit. 3/2 to 8/5. And then from 8/5 to infinity. So as we're looking at that, we're looking at the y coordinate or y value of the whole and horizontal asymptote. And notice that you have to go in order. I mentioned this in an earlier video. Make sure that you do the one that occurs first from least to greatest. That's why we've been stressing interval notation all along. I think there's only one more example to get us to the end. Notice that they also give you the denominator in the directions of it as this quadratic expression. So we can piece some more things together and answer a few more questions. So for whatever reason now they start with the domain. So infinitely to the left, first time that the x is undefined is -1, and then from -1 to 3, and then from 3 to infinity. Does either factor in the denominator also exist in the numerator? Well, let's look at what that even means. So what does this mean is if we have a canceling factor, so this implies, here's my symbol for implies, that there's a hole in the graph in G. So what does that mean is if we look at the undefined values, there's a reason why I'm only looking at this one, because this is infinite. This one is infinitely down. It's a very, very large negative number. This one's infinitely up. So this is my clue that that's a vertical asymptote. Well, as you look at this one, this would be a hole. And I know it doesn't ask for it, but I might as well mention it and give you hole at -1. Let's go ahead and state what the y value is, -1/2. And so what that means is when you factor things, you're going to have an x plus 1 on top and bottom. Now, obviously, there's a little bit more to this. There might not be a second term in the top, but there's definitely a second one right there. Let's answer that question. Is there a factor in the denominator but not in the numerator? This one is yes, because it's a vertical asymptote in g of x. That's what that means if you have a factor in the denominator, but it does not exist in the numerator. So we know that there's a vertical asymptote. I sort of already explained it at x equals 3, because as you look at that undefined value, one is getting infinitely negative and one's getting infinitely positive. So for sure. So what that tells me is, based off of everything else that we have, it's that x minus 3 is a factor in the denominator. Now, clearly, there's these pieces as well that I'm not going to write again. There might be another factor in the numerator. Actually, there has to be, but we'll get to that in a second. Okay, is there a horizontal asymptote? Well, as you look at the end behavior, go back up, let me change colors again. It looks like we're getting closer and closer underneath the horizontal asymptote. This one's above the horizontal asymptote, but notice the y values are about the same. One's below, one's above, but we can for sure say that the horizontal asymptote would be y equals 2, and I want the end behavior. As x approaches infinity, g of x is getting closer and closer to 2, and same thing as x approaches negative infinity, g of x is closer and closer to 2. So what must the leading coefficient of the numerator of the equation be then? Well, let's look at the bottom piece. Let's switch back to the bottom piece is this. So we have 2x squared minus 4x minus 6. Well, let's go back to this statement. So we have y equals 2, which has to be when you divide your leading coefficients. Remember, the denominator is this. Well, let's put an a right here, because I don't know what it is yet. In order to get a non-zero horizontal asymptote, then when you divide the leading coefficients, it must equal that value. So essentially what this means is that horizontal asymptote, the leading coefficient in the numerator, when you divide by 2, the leading coefficient in the denominator must equal 2, the horizontal asymptote. So multiply 2 over, 2 times 2 is 4, equals A, the leading coefficient in the numerator. Now this one, I think showing your work is good, but if you wanted to write out your own explanation for your reasoning, I would support that. And there's no homework in this assignment, 3.5, but these are excellent. This is excellent notes. You definitely want to reference these as you're studying for your test, and especially if it's still a take-home test by the time we get to this, that you go back to these notes while you're taking the test.